how to access and build on top of the IGVF data portal and catalog. So if we let me pull up our diagram of the IGVF resource that we had before. This is kind of how we imagine the many ways that our data and models might be used by the broader community. And we know that any particular user, like Andreas walked through some use cases, may, have interest in particular genomic variation, or particular genome functions for particular applications. And so the DAC and the catalog working group, or the two DACC groups and the catalog working group, have considered, how can we best support all these myriad different use cases? And that motivated the diagram shown previously by Jesse, that we have this data portal where we have data and analysis files, and then we have a catalog API, which allows to visualize and see kind of a nice curated filtered version of that. And so I'll first just show you some pictures of the data portal. That's more of like the complete representation of the data and the analysis files. So in order to support rigor and reproducibility, we have highly structured metadata behind any analysis you see. So there are, for example, like in the center here, there are biosamples. All of the cells or experiments that have been performed are performed in biosamples. When those are described, we use common ontologies. Likewise, for any kind of treatments or compounds, and all of the assays are associated with protocols. So that's a very structured way to get information. So here's just a little screenshot of the data portal at data.igvf.org. So you can click on any analysis and go in to see the particular biosamples that were involved. Clicking on those, you might be able to find information about the particular library. So that could be, for example, the design of sequences or regions that were tested. And then that will take you further to structured metadata on the exact, in this case, variants that were assayed in an MPRA data set. So it's all structured in a way that you could kind of go back and figure out what was done to which samples and why. Then if we zoom over to the catalog, that this is the more filtered and curated set, that's been built into a knowledge graph in which the biological entities, such as variants and elements and genes, are nodes, and experimental measurements or predictions of impact of those functions are edges between those nodes. And so this is, I think we already saw a similar page from Andreas' slides. This is a typical variant page, and you can see, connection to target genes, and you can visualize it as a graph. I'll just mention that if you're searching at catalog.igvf.org, it's possible you can type in any string, but you can also, with a backslash, pull up kind of a filtered version of that, which lets you just look within a certain subset of the nodes. And then going further into the back end, this has been developed and released also as an API, so you can also build on top of this. We've got multiple ways of learning how to do that. So you can look at Python notebooks, which query the API. You're literally like walking along the graph. If you start with a variant, you can pull up elements or genes that are connected to it and get scores and p-values. We also have an R package in Bioconductor, which also lets you kind of query the IGVF data through various different APIs.